Hello and welcome to physics. We are going to look at work, energy, and power. Work. What is work? Work happens when transforming energy from one form into another. Okay. So when I lift an object, okay, I'm lifting up the object. So I am applying a force over a certain distance, and that is work. The object will not hover by itself. Moving an object. An object will not move by itself. I have to apply energy, okay? And that is a form of work. And lastly, slowing an object down. When an object is moving, objects need a external force, as we've seen in Newton's third law or first law, to slow it down. And applying that force is doing work. Okay, and all other forms of energy transfer. Okay, so what's the formula for work then? Work done is equal to force, okay, times distance moved in the direction of motion or movement. Okay, so work done, guys, is a scalar. It does not have a direction, okay, but force has a direction, so force is a vector. And distance moved in the direction of the force is also a vector, because we can already see here that the direction is important. Okay, so work is measured in joules. So the W in the formula measures the work, or how many joules of work did I do. The force is how many newtons of force that you apply in the direction of motion, and how the distance there is how many meters did it move. Okay, so force times distance, but your force has to be in the same direction as your distance, otherwise you're not doing work. So when am I not doing work then? Okay, if I'm not making the object move, work is force times distance moved. Okay, so if I'm pushing against a wall and the wall doesn't move, I am not doing work. You can push and push and push the whole day, you're not doing any work scientifically. Okay, when forces is not in the same direction as the direction of the distance moved. Okay, so if I carry my school bag on my back, I'm applying an upwards force on the school bag, but I'm walking forwards. So my force is vertical and my distance being moved is horizontal. Therefore, you can carry the heaviest bag the whole day long and you're not doing any work scientifically. Okay, so carry your backpack's not doing work. The only way that you will do work on your backpack is if you push it over the floor, okay? And that force horizontal, causing a horizontal movement, will be work, okay? Now, so let's look at the formula and apply. How much work is the stickman doing while pushing a box 5 meters with a force of 12 Newton? Okay, so firstly, which one must we have to make sure is the work is done, the force is done in the same direction as the displacement. Therefore, we can apply the formula work is force times distance, which is 12 times 5, and that gives me 60 joules. Okay, now work and power when force is at an angle. Okay, when the force is at an angle, you will only get the component in the direction of the work applied. So here we can see our stickman is pulling the object at an angle. Okay, he is slightly pulling upwards and slightly pulling sideways, and therefore he's pulling diagonally. All the force that he is applying upwards is not contributing to the motion. It's only the force that he's doing horizontally. So we would say his horizontal component of the work, and therefore we can use trigonometry and we can calculate his horizontal component. In this case, it would be 12 cos 25, okay, would be his force, and we would multiply that by his distance. Okay, so let's look at an example of how much work do you have to do when 12 Newton of a force were applied at an object at an angle of 25 degrees above the horizon or the horizontal to move an object 5 meters horizontally. Okay, so first things first, we are going to need to calculate the horizontal component of the force. the part of that 12 Newton that is pulling horizontally. And to do that, we'll use trigonometry. We calculate using cos, and we say cos 25 times 12, and that gives us our component horizontally. So 10.9 of that 12 Newton is horizontal, and only that 10.9 Newton causes the object to move. Then we find out how much work is done by this component. So we take the 10.9 as the force, we times it with our distance, and we calculate our energy, which is 54.5 joules. Okay, that's a brief summary of work or energy or power or all three. I hope you have understood this, and if you've got any questions, please leave me a message. Thank you.